Okay, good afternoon, everyone. Thank you very much for coming in. So our objective for today, we've drawn most of the main elements of this drawing last class. So for this class, I think what I was planning to focus on is to lay out these stairs in elevation. Quite quickly, we will basically just grab this and then copy it to below. I can show you how to lay out this railing, these walls as well. And I think that should cover all of the new elements that we have in this drawing. After that, all that's left is adding location, and then some small elements like the bridging, or the details in the chimney, which we're going to just focus on doing by eye. So is there, other than these things, laying this out, this and this, and then later in this class I'd like to focus on doing the stairs below. Other than those, is there anything that's worrying anybody on this drawing? Is there anything you look at and you're not sure how to draw or how to get started on? If there is, let me know. I'm happy to do that with you guys. If you can't think of it now, no problem. I'll get going. And if you think of it as the garage roof, this thing. So we did do that. There is a YouTube video. I don't know if it was clear or not. If it wasn't clear in the YouTube video, let me know. But we did draw it last class. Okay, but that's okay. If you have any trouble with it, let me know. We can always go over it again. I think what I would start focusing, so we'll focus on getting those things done in the first segment of the class. Then I was thinking about this. I think we may be better off starting with this portion, drawing this part here. Because in drawing this, it will give us the basic stair, or basic tread. So one step, which is a tread and a riser. And after we draw that, it will make it easy. It should make it easier for us to kind of copy and paste that stuff along the actual stair that we have to build. Okay, so we can see that from the inside. Let's see if we have the stud wall drawn. We do. Okay. So from that stud wall, we go 1120 over, and that gives us, that's the edge of the stair. That dimension must be wrong because this one is also 1120, and it looks a lot smaller than this. Okay. Sorry? That's 1220. This is 1120, but this distance is also 1120, which I don't think that cannot be correct. So instead, maybe what we will do is, let's go from the inside wall of the chimney if we have that. That's our stud wall. No, we don't. Actually, we do. The inside wall of the chimney is in line with the concrete block. Sorry? Can we use a floor plan? Yeah, that'd be great. Maybe we have it already drawn. So I believe we're looking for the distance from, oops. Okay, so from here to here. So 1941 is what I got. That's not a bad idea, so let's stick with that for now. So offset 1941. Okay, then the stair width was 1120. And then I think after that, sorry, my keyboard is messing up, so it keeps opening up these tabs. If this gets too clumsy, I'll stop the recording and I'll just do it live for you guys and re-record it after. Okay, so the stair width is 1120, which we have. There's a railing width here, which is 100, so we can add another 100 offset, and then it should be 1220 to get to this load-bearing wall. Oh, using the wrong keyboard. Okay. Repeat offset 1220. So now we should be at that wall, and that wall is 89 wide and it has a beam above it. We'll worry about that beam after. So I think what I'll do next is I'll trim these lines down a little bit. Okay, I'm just going to try to zoom into the beam at the top here to see what it's made out of and to see how we can draw it. Doesn't quite tell us, so we may have to guess, but it does look like if you zoom in close, there's two 2x4s up here, and these are either 2x8s or 2x10s, because they're slightly smaller than this. I'm going to guess they're 2x10s. So two 2x10s, and it is wrapped in something which would make sense for it to be drywall. So that should give us enough information to draw it. So I'm going to go back here. I'm going to copy a 2x4. I'm just going to grab one from this wall that we have here. Okay, now I'm going to draw the 2x10, which is 38 by negative 240. No, these are, so I guess I was wrong. It's not it's probably a 2x8, because these are 2x10s that we have up here, and we could see that it's smaller than that. So 2x8, just going to calculate it here. 7.5 inches times, so it's going to be 190, or actually better would be to look it up. You can go online and look it up. So nominal size,
184.
Is it 184? 2x8, yep. 38 by 184, perfect. at 38 by -184. I'm going to draw a couple of lines through it to give it the X.
What's the size?
38 by 184. Okay, and then I'm just gonna draw, or I'll leave it up to you guys. You can draw the plywood around it, sorry, the drywall around it and encase it. Or we could quickly do it here too. So I'm going to use a polyline to go around. You can do it just as regular lines as well. The polyline makes it a little bit easier because I can just do one offset and it'll offset the whole U-shape thing. I'll show you what I mean. So offset whatever this distance is. So this first offset here from the inside of the stud wall was 1957, and then it was 1120, and so on. Now let me know if you need more dimensions. So you can see the dimensions I was going off of to offset it are right here. I mean, this one is 1957. We had to confirm that to ourselves. So we looked at this one. This one we trusted, so we went 1120. And then this one is 100. And from there to there is 120. Okay, so we've got our column, or sorry, our beam, and we have our central load-bearing wall. And so now we can just go up and copy that. It should be ideally lined up directly above, which we do have. So there's another wall right here, and we can assume it's 89 millimeters wide, which is 2x4s, two 2x4s at the top, one 2x4 at the bottom, and drywall on either side.
How much did you offset?
Sorry?
The polyline?
Oh, I just, whatever this distance, I'll check. I can't remember if we did 16 millimeters for drywall or 12 or 13. It's the difference between 5/8 and ½ inch. Different people prefer different things. I did 13 millimeters. Just copying the 2x4s into the wall, and then I can clean up.
Okay. So we've got our top wall in. And it's a similar situation for the bottom wall.
So here next to the steel beam, so there's some kind of a detail that they're giving us here. So in a real drawing set, they don't give us all of the drawings, but in a real drawing set, since you have this 5 on 5.6 and 4 on 5.5, it means that there would be a page somewhere with a drawing 5 and 4. And so you go to page 4 and 5, and you look at detail 5.6 or whatever happens to be on that page. And they would tell you all the materials and all the dimensions in here in a much clearer way. Since we don't have that, we're going to have to guess a little bit. So what I would guess is that in an idea that there's some kind of a steel plate or most likely just plywood underneath it. So this is a column that's supporting this.
So I think since we have the wall above, it might be easiest for us to start drawing this from the top down. They've got some kind of wood blocking, I think, under there. So we're gonna assume that's a 2x4. This beam, let's make it 200 millimeters deep. And then we'll just draw the rest of the column. They do have a 2x4 at the bottom there, okay. So I'm going to finish off this top wall by copying a 2x4 to the bottom. Okay, now in the drawing here, oops. In the drawing here, it looks like there's some kind of a wood blocking, so I would say that's 2x4 blocking they're somehow putting underneath this. Now since we don't have a close-up, we have to guess. So I'm gonna offset by 38 millimeters, because that's how wide a 2x4 is in its smallest dimension. Then we can guess here, we can say it's 200 millimeters on either side. Okay, now we can switch to steel if we have a layer for that. Okay, if not, we'll stay on our existing, well, we won't stay on wood, we'll stay on, I guess, AE beam. Do you mean the I-beam?
Yeah.
So we're going to draw that right now. I'm going to guess that it's 100 by 200. So what I'm going to do is, first I'm just going to draw it, and I'll move it in place after it. I'm going to go 100 millimeters this way. Okay. Then I'm going to go 10 millimeters down. because I'm gonna guess the steel is 10 millimeters thick. Now it's gonna have a 10 millimeter flange going down the middle, so I have to divide 90. It's 100 minus 10, which is 90. 90 divided by 2 is 45. So I'm gonna go back 45, like so. I'm gonna go 180 down. 45 back, 10 down. I think this might make more sense once it's drawn, so I'm just going to press ahead and draw it here, and then I can answer questions.
So basically this is 100 millimeters across. And then the width of the steel is 10 millimeters. So I went 10 down, and instead of going 50 back to get to the center, since this is 10 millimeters wide, I just went 45, 180, 45, 10, and so on.
What's the offset in the rectangle?
This, at 38, I'm assuming they're doing some kind of bridging across with 2x4s. It's really unclear what they're doing with that. This, it's 38 millimeters across, and offset 200 on either side of this, so it's 289. Sorry, 489 from side to side. I would do it differently. I would just basically say, since we don't really have a lot of detail on what we're doing here, I would offset this down 38 millimeters and make this as big as you want, just so it looks approximately like what it is. And I would make this I-beam approximately what it is, because they haven't given us that info. So I guess we're going more just based on a little bit of intuition, but I guess logic. So like what would make sense to have there. So there's an I-beam going this way across the house, and it's supported on columns. So draw the I-beam. They have theirs actually a little bit lower. Theirs goes below the beam. But I'm not sure, like 100 by 200 is a standard size, so I don't know what size they're using. And since they don't give us any details, we're going to go on our own. And so we have our I-beam, and now I'm simply going to draw a column below it, going right down to the concrete floor.
So we kind of have this. They have some kind of wood blocking there, but that's fine. It's an 88.9. We're gonna call it an 89 wide column that goes right down to the concrete floor, and then it has some kind of anchor in there. So I'll show you how to draw that in a second. So the way I would do this, I would just draw a center line. So I can center that. Actually, I don't even have to do that. I have an 89 millimeter wall right above it. So I could just do this and extend these lines. Okay, I'll trim them off so that they're not too long. Delete the extra parts. And I'll extend them down to the floor. So our column is now at the floor, and here it's too small to see what detail they're doing, but I'll show you an image of what these columns usually look like. Now they're not always a jack post like what I'm going to show you right now. These type of posts are more for like temporary posts for when you do renovations and stuff. You can kind of adjust the height if you want. Lots of people leave them in after the renovation just encase them in drywall. I guess that's good enough, especially if you anchor it at the top and the bottom. But what you're supposed to do is get a custom made steel post. You go to a fabricator and get it based on a very detailed drawing. Not detailed, but just very accurate down to the 10th of a millimeter or whatever. And they'll build you a post. But they look kind of, even the ones that are built look kind of like this. They will have a square post. This is round, they'll build a square post. You have a base plate and a top plate. And usually the top plate and base plate will have holes in it so you can drill it into the concrete or the wood. And the same thing with our post. So what they're probably showing us down here in not very much detail is how that base plate connects with the concrete. And so I would say the way we can show that is that we will get, they're probably sinking the base plate, I guess, into the concrete so later you can tile right to the edge of the column. So since our column is 89 millimeters wide, why don't we give it a, I don't know, a 200 by 200 base plate. So we'll say at 200 by 10 millimeters. And again, it doesn't have to be exact because they don't give us the dimensions, but that's what I'm going to center on the base of my column. And so now I'm going to move it to here. And the other thing they have is they have something similar to our J-bolts, the ones that we used in our basement wall. Now I can't seem to find them. Okay, at least in our original wall. There we go. It looks like they have that, but they're sunk very low. So I'm just going to copy this. And I'm going to put it onto our column. I'm just going to position it at the edge for now. And I'll move it, let's say 25 millimeters in. And mirror it. And so this might not make sense yet because we've got this bolt going from the plate down, but it's going through the concrete and sticking into the gravel, so that doesn't make any sense. But what they show with this dashed line, and I'll go back to the drawing in this right now just to show you what I mean. Sorry. Here. So I believe they're showing this dashed line down here. That's an extra bit of footing or a piece of concrete poured as a base for this column. So in their floor plan, we haven't seen this because they don't give us a basement plan. So all this may seem very unusual if you haven't seen this in the drawings before. But with this, what you can kind of deduce from this is that they have a line of columns in the basement. And in every column they have something called a pad footing, which is a big block of poured concrete. And so these bolts that we show actually sit inside of that concrete. And they do give us a dimension, 200 by 200 thick steel base plate. Okay, that's in the group, so we've got that right at least. 150 by 150 by 10, minimum anchored to footing with 2-15 bolts, 100 minimum inch, so it doesn't give us the size. What we could say is it looks like approximately 6. I don't know, it looks bigger, but I would say no more than, we don't need any more than an extra 200 millimeters on either side, and we could make it, I'm going to change the drawing here and say we would go probably 200 millimeters or 300 millimeters tops to that.
I think it sounds big enough to find
Thank you. 850 by 850.
Okay, that's huge. Deep concrete, like 500 feet. Okay, if that's what it says, we'll follow it, but this is almost certainly overkill. We could probably get away with half of that.
Okay, so if you decide to draw it smaller, I'll understand, but just because like we have an example, so we'll stick to it, we can draw it that size. So 850 by 850 by 500. So essentially what I need to draw is a rectangle at 850 by negative 500, and I'm going to center this onto my column, and then I'm just going to make all of these dashed lines. And if they look too big, I can always type in LTS, line type scale, and make it a bit smaller, maybe 5. There we go. If I want, I can pull this down to here. And that's done. So we have our walls in the middle. Now we can detail our stair. This should be relatively simple.
So we have these 3 lines. We know that this is some kind of a wall. Somewhere here we have a railing. And we should have from our detail drawing the riser height. So we simply strike a line and just start offsetting on it to show our riser heights.
So I'm going to go down here. And so our rise is 188.4. Now I guess we can be pretty detail oriented in this, so we might type in the actual distance 188.4 instead of just rounding up. So I'll grab actually I don't even have to grab a line. Hang on. I will just offset our floor height by 188.4 and go up. Now before I offset further up, I'm just going to do a bit of trimming here. Okay, and then I can offset again, 188.4. Now if you're offsetting, I think you can just keep clicking the next line and kind of leapfrogging, similar to the way we did when we copy a lot of stuff. Once I get to the top, if I can't fit anymore, that's it. I just cancel it. Now, I'm not sure if ours looks the same as the student drawing, or as the example. But if it doesn't, we're not going to worry about it. Yeah, they have a line closer to the top there than we do. But we know our floor-to-floor height is correct. So I'm not sure why their drawing is different, but we can be confident that ours is correct. And so the last thing I'm going to do is put a railing on this side. So I'm going to just guess, let's say the railing is 25 millimeters away from the wall. And the railing itself might be, you can imagine, there's all kinds of different railings, so you can even space it out and go by eye, but I would say, let's say 70 millimeters, so 7 centimeters. I'll offset that in, and I'll simply trim all the lines that are intersecting those 2 lines, like so. So once we have that, we can basically just grab this entire thing and copy it to the floor below. And the reason I'm not too concerned about my stairs looking a little bit different in this drawing than the example is because this is not a drawing where you'd get the details for the stairs. You would do that from the stair section which we're about to draw. That one needs to be extremely accurate. Here you're just kind of showing the location of the stairs, not necessarily how it would be built. And so we now have the basement stair in. But the one thing is your railing, if you think about a railing, as you're approaching the stair, the railing doesn't go all the way to the floor. It starts about 1 meter in height on base level. And so I'm going to offset this line up, let's say 1,000 millimeters, and that's where I'll end the railing. I'll trim off the extra parts. Sorry? I did 70. Sorry? Yeah, 25 and 70. But it's, again, it's up to you guys. You can, as long as there is a railing, that's required. But there's different shapes and sizes of railings, so you can leave it up to your own judgment. So I'm just going to correct the look of the stair because our railing, obviously it doesn't start at ground level, so we're going to keep this one higher. Okay, and now we have the stair as it emerges in the second floor. And so here there is another wall with another beam, and we can draw that in a similar way. I trust that at this point you guys know how to take this off of the floor. Actually, no, we don't have a floor plan on the second floor. And we don't give us a dimension. Unfortunately, we'll have to guess again. They don't give us a dimension here for this wall, and we don't have a floor plan, I believe, for the second floor. So we'll have to assume that the stair comes up. We can't have a wall on top of the stair because it's still an opening. So well, we can deduce this a little bit. If you cut through the stair where you come up to this floor, there's basically a hole in the floor from here to here. So let your stair come up. So the wall has to sit outside of that. So we can assume this wall is 89 millimeters starting at the edge from the floor, and it goes all the way up. So what I mean is that I would draw the stair railing first, actually. So what I'll do is I'll grab a line, extend this up. Okay, I'll go back to the drawing. Let's see the other side. It pops out here a bit. I guess it pops out beyond the stair opening by about 100 millimeters. They may have a thicker railing up there. Well, the railing actually just wraps around to protect you from falling into the stairwell. So we're going to say offset 100 this way. And then I'm going to offset 1,000 millimeters to get the top of the railing. Could be 900 depending on what they're doing for their railings. they're not showing us. Okay, so they have a railing up top. They have a couple of pickets. Those pickets are usually spaced with 10 centimeter gaps between them, and then they have a wall. So this wall we know is 89 millimeters. I'm going to trim off the extra stuff here. Delete that. And now I think I'll extend this wall first. We have we have all the information we need to finish this wall. So I'm going to extend it up, and I'm just going to see what kind of beam they have up here. They have two 2x4s and a space, and then two 2x4s down, and a couple of lines. I'm not sure if that's a pocket door or something else happening between it, but we're not going to worry about that. I think what we'll do instead is we'll copy the detail we have here and modify it. So I'm going to grab all of this and copy it up here. I'll clean up the drywall a bit so it connects properly. And over here it looks like they don't have 2x8s, they have 2x4s. So I wonder if instead of drawing them again, if I could just do something like this. I'll just offset by 89 and adjust it. Like that. And then for the other one, I can just copy the one I just made. And that's it. Now to finish the railing, this is again up to you guys. I'm just going to offset the top part here by 70 as well. We already have a 70 millimeter railing, so we may as well keep the top part of the railing the same. Okay, we can fillet this. I went 1,000 millimeters above the floor, but it could be as little as 900. So usually railings are somewhere between there. So now I'm going to offset by 100, and these are going to be the pickets for the railing. But I just realized I need to trim a little bit more below, just so things don't get messy. Okay, now the pickets are, you can see kind of pickets between the panels of the railing outside there in the hallway, but in this case we can say, I don't know, they're 25 millimeters. So I'm going to say offset 25, like so, and then I can just copy them doing that leapfrog technique we've done several times. Done.
I here you can see it's got 2x4s in it. So as soon as you see a 2x4, you know it's 89 millimeters wide. So this wall is 89, and it's in line. This is where the stair as it cuts to the floor here, and it's opposite the 89 millimeters.
Okay, so
Hopefully that made sense. I'm gonna move on, just to keep this moving, so I don't keep you guys too long. I'm gonna move on to the stairs. And we're gonna start the stair detail here, and then I'll show you how that can translate to the main stair section. I'd like to cover at least the basics of that today, so that next class I can show you, how to do the elevations, which are quite quick. I think we can knock those out during the class. But I just want to keep, sorry, I apologize to rush you guys, but I just want to keep it moving so we don't, so at least we cover all of the content. And again, all this is going to be online, so
if you need to, you can go back through it at a slower pace. Or of course I'm here, you can ask me anytime you need anything. Just gonna plug in here so I don't lose my work. Okay. Oops. Okay, so as long as this still sharing.
So I'm going to start with the basic thing here, which is just drawing this as a rectangle at first. So we know it's 263.4, and then we need to know how deep is it. And so it doesn't show us here, but here it says 30 hardwood tread. It's 30 millimeters deep, so we're going to draw a rectangle 263.4 by 30. And with stairs, by the way, you'll almost always find, if they're in a residence, they're usually made out of wood. And if they're made out of wood, it's going to be hardwood. So it's not going to be any type of plywood or layers of, veneers and stuff, because the idea is that as you walk up and down these stairs, they'll eventually wear down. And to refinish it, if you call somebody in to refinish it, they're just going to sand off the top 2-3 millimeters, make it nice and smooth again, re-lacquer it, paint it, whatever you had, and life goes on. But if you have plywood or anything like that, your plywood is made up of 1.5 millimeter thick layers of wood glued together. So as soon as you sand it, you're now going to expose the other layers beneath it, and you're going to see that it's going to look very strange. So it's almost always solid wood here and solid wood here.
So let's just start with the first rectangle. So 263. Oh, sorry, it's going to be 263 plus 25. So I guess that would give us 288.4 by 30. So I'm going to move to the side here. Where's my wood layer? Grab a rectangle at 288.4 by 30. So I have a rectangle. Now, I know that my nosing is 25 millimeters, so I might as well show that face right there. And then it tells me that the radius of the nosing is 5 millimeters, so we'll use the fillet tool to do that. So what I mean is I'm going to at first draw a line here. Actually, you know what? Since I'm going to draw the vertical line down, I may as well draw it. Oh boy, I hit the escape button. May as well draw it the right length. So sorry, I'm going to jump back to the drawing one more time. And I know the vertical length is 188.4. That's the riser. So I'm going to go here, line down, 188.4. I'm going to move this line 25 millimeters to the right, as is shown in the drawing. And now I'm going to use the fillet button. So we've used this button before, but we always set the radius to 0. So this time I'm going to click where it says radius and set it to 5. And I'm going to want to do multiple instances of this. So I'm going to click multiple, and then I just go at it. One here and one here.
We have this piece of wood around. I'm not going to worry about this notch yet. We're going to do the notch at the end, because these are kind of arbitrary. You don't really show these in your drawings. They're called. There's a whole. We're doing so-called architectural drawings, and you'll probably stick to them throughout the entire education you have here at Humber. But once you enter the industry, you're gonna. It's sort of always a surprise. It was for me too when I graduated. There's a whole other set of drawings. There's many other sets of drawings. You'll have engineering drawings, landscaping drawings, electrical, plumbing, mechanical, so on and so forth. But those all integrate with architectural drawings. And they all happen before you start building. Once you start building, there's a different type of drawing called a shop drawing that happens. And that shop drawing is basically, those shop drawings are all about like super fine level details. So for instance, if I'm building a stair, I would give a drawing to the stair person that shows all of these distances, but they don't show how the stairs are assembled, and they don't go into the finer details of these wedges and how you notch the stringers and stuff. There's a whole bunch of details in here that we wouldn't bother to show. And we leave that up to the carpenter or the trade doing it. But we need, usually what happens is they create shop drawings of what you draw that shows all of that detail. And then they send it back to the architect for the architect to verify, not that this is correct, not that all of the notching and stuff is correct, but to verify that the parts that they designed are correct, to make sure this distance didn't change, or wherever it says this distance didn't change. So basically they, in a nutshell, they add a bunch of detail that tells you how they're going to build this thing, and your job is to verify that it still operates the way you intended. I don't know if that makes sense. I know I'm going like way ahead here. And so the reason for that, there's two reasons. One is that now you both have an understanding of how it works in detail, but there's also this liability difference, which is that let's say they do a shop drawing for this door, and I approve it, but they made a mistake, and they made this door handle on this side. And now, but I already approved the drawing, I gave them a check mark, I said, yes, it's good, proceed with fabrication, and they install it. Now that it's installed, it's my fault if it's wrong. Well, it is wrong. So now it's my money as an architect, I have to spend my own money for flipping all of these doors around or rebuilding them or whatever. It basically becomes my problem. If I catch them when they send me the shop drawing back and they say, yes, everything is okay, but you have the door handles on the wrong side, please revise, and I send it back to them, then it's their problem. They have to revise it, and then they build it according to the correct drawing. So it's a way of working out problems before they get built. It's cheaper to resolve a problem on paper than it is in real life. So that's what shop drawings do. And number two, it's a way of assigning liability. So if the shop drawing is correct and somebody builds it wrong, you say, nope, shop drawing was correct. Sorry guys, you guys have to replace it. I'll work with you to make it easier, but it's your cost. So sorry to go into that level of detail, but that's why I'm not going to worry about these little things. I'm going to treat them kind of as afterthought. I'm mainly worried about the riser height and the run. And in fact, I've already made a mistake. I did the riser, this thing, at 188.4, but that's incorrect. It's from the tread to the tread is 188.4. So I should have been, this line should actually be 30 millimeters less. It should be less the thickness of the tread. So I've already made a mistake.
So I'm going to go back, and instead of 188.4, I'm just going to draw a line over top of it. It's going to be 158.4. And then I'm just going to pick the longer line and delete it. And this thickness of this wood gives it to us here 22 hardwood riser. So offset 22. Now, what I've drawn, I have up to here, so this line, this piece drawn, and this piece drawn. So technically, if I take what I have and I copy it so that this corner becomes this corner, I should be able to get a second stair out of it. Sorry? No, you mean from here to here? Yeah. 158.4, correct, yeah. So I'll show you what I mean. And I want to expand this to 2 or 3 steps before I throw on any details. So copy. So from here to here should give me what I want. So I'm going to see, I hope I have an annotation style set up that'll give me decent sized text here. Okay, there we go. So 188, let me see if I can change. You don't have to do this, but I'm just going to show you, I'd like it to be a little bit more accurate. So I'm going to go in here, manage text styles, we're Arial 20 millimeters. Okay. Do I have an accuracy thing here? Where is this? Where would I set this? Okay, I'll figure out where to increase the accuracy in a second. 188.4. So if I just do a measurement, it'll show me that it is correct. So I can get rid of that. And the length of it, oops, is 288.4. And that's exactly what it should be. So we are correct. Now in this stair segment here in this detail, we see the end of one stair, we have 2 full stairs and a little bit of the extra one. So I'm just going to go ahead and copy that. And so this stair ends somewhere here in that drawing. And now I can add in the other details. So we've kind of done the difficult part of it, and now we're just going to add in the details. So I'm going to connect the thickness of this to that. I'm going to fill at that edge. And I'm just going to draw a notch. And then I'll copy that throughout. And I'll draw this little detail and copy that throughout as well. I'll show you what I mean. Sorry? Okay. Sorry guys, just need a second here. Oh, wrong keyboard. This may take me a little bit longer to fix. I thought there would just be a command for it.
What I suggest is, for now, just have this open, yeah, let's start this. Hold on. Because it needs to scratch. So I can see this. Put it in the line, just start trying this way. And then the class we can make it. Okay?
So back to this drawing, I'm just going to use the fillet button here. Now remember, don't just use the fillet button because we set the radius to 5. So I'm going to reset it back to 0. Close this. Oops, that's not what it, oh great. Sorry, my keyboard is freaking out here. Every time I hit escape, it opens a new tab for some reason. Okay, so this is going to be tough to fillet because it's a closed shape. I'll show you guys a new command here. If you type in explode, like the most exciting command now, they're all pretty boring. Type in explode, you'll break this into smaller parts. So right now, for some reason, it's become a polyline. I guess I know why, because I started as a rectangle, so it's still treating it as a rectangle. But if I select it and I type explode, then now it's broken apart into individual line segments. So now I can use fillet on it, and it should work just fine. I can take this line out, and we can notch it the way it's notched in here. So it's letting us decide how to notch it. So I'm going to go here and say, let's say that notch is 10 millimeters. So I'm going to go 10, and this is 30 deep, so I'm going to go halfway, 15, back 10, and then back down. There's no real, I keep hitting escape, I did that again. There's no wrong way to show it, I guess, as long as it looks approximately like that. And then we have a notch up here as well. This one is what, 22 millimeters wide, I think, yes. So I'm going to go 11, I'm going to go halfway. So grab a line, go up 15, over 11, down 15, and then just trim it. And now I can just kind of copy that solution to the rest of the stairs. The tread is 30.
Okay, so we've drawn a couple of stairs. They have these wedges in here. Which shows the rule that that's this square. Okay. Maybe there's a little line here. Maybe there's not some kind of fluid or whatever. I'm not sure that must be fine. I'm not quite sure. But that's okay, we can just draw them. But since they give us no dimensions, we can just eyeball it. So what I will do is I'll just draw it on one stair and up. So I'll draw a wedge, it goes like this, making sure it stays horizontal here. And then I'll draw this wedge, and I'll make sure it stays horizontal to that same line. So then when you copy it, it'll line up. Perfect. I'll show you where I mean.
So, and they didn't give us any dimensions on this, so I'm just gonna go and guess it. There we go. It's a pretty good looking wedge. Let's do another one here. Done. And so now I should be able to copy these. In fact, before I copy it, I'm just going to switch the layer. It seems to me that that layer is a little bit thinner. Yeah, the wedge layer, well, maybe not, but I would put it on a thinner layer, would be my guess. So I'm going to go and put it on pattern so that when we print it, it shows up a little bit thinner. And now I'll just copy it to the stair above and to the stair below. And this one is, I just realized, cut off, so I shouldn't have put that extra. I'm just going to cut this here to make sure I don't get confused about it being a full stair. Okay, we're almost done this stair. We're really close, actually.
We're going to put a bit of a hatch on it. That's the easy part. And now we're just going to do a little bit of spine. So here, this is what I'm looking for. So that millimeters, 90 millimeters. If we connect these corners together with a line and offset 90 millimeters down, that'll give us the bottom of the stringer. And if we connect these tops together and offset 25, that should give us the top of the stringer. The stringer is, so if you picture stairs as you're walking down, when you look at the side of the stair, you'll notice there's a diagonal piece of either metal or wood that all the stairs are attached to.
I'll try to show you a picture of it. And that's what we're just drawing from the side. This is the top of the stringer, that's the bottom. On keyboard. Okay, that's the one stair without a stringer. Okay. Here.
So the stringer is this. So we're just, it's saying that it's offset 25 millimeters above. I think it's at 90 millimeters below.
Correct, 90 and 25. So what I'm going to do, the bottom is going to be easier. We have sharp corners, so no big deal. I'm going to connect all of those together. Offset 90. There we go. And if I want, I can extend that line up to my other stair like that. And then it did say something about drywall, so that's going to be another 13 millimeter dashed line offset. Okay. And now here, I'm just going to be a little bit careful, because if I draw a line connecting these round pieces together. It's not exactly what I want, I think. Although it does look like they're going from the rounded nosing, so okay. Recommended on all treads and required when run is less than. Okay, fine. So I guess we can go from. No, it's gonna get no. We're playing with fire. The reason I don't want to do that is because odds are this is a curve. It's got a lot of little parts you can click on. The beginning of the curve, the middle of the curve, the end of the curve. It's going to be snapping to all kinds of different things. There's a high chance that if I snap to something here, I'm going to snap to something slightly different here. And if I'm just even a little bit off from this point, not being exactly the same on this point, when I extend it, now my stringer is going to be not exactly parallel to this one. It's going to be diagonal compared to it. So it's going to look okay if I look at it on any one stair. But if I expand it to the entire stair section, it's going to start to look stupid. It's going to look off based on everything else. And then you have a line that doesn't fit, and stairs are already complicated enough as they are. The trick with doing a stair is drawing everything really precisely, and then being very precise as you scale it stair by stair to the whole thing, so that we end up at the right height. If you start getting lines that are a little bit off and diagonal, it's going to cause you potentially hours of extra work. So I'm going to play it safe, and what I'm going to do is go back to fillet, make sure my radius is 0, enter, multiple, and I'm going to refillet these curves to give me a point. I know it's a bit of extra work, but I think it's worth it, so that we don't have issues with it later. And then I'm going to trim those extra bits off. I don't need them, I just needed it as a temporary thing. Okay. Now I'm going to offset 25. That's the top of my stringer. And then I'm just going to extend it as far as I want. Okay, so I think we're done here. We just need to do the plywood hatch. And so to do that, I'm going to type in hatch. And here, if I click, it gives me a pull-down menu of all kinds of different hatches. And if I scroll down through it, usually there's some kind of a wavy hatch. Something with wood or plywood. Maybe I'm not going to find it by doing this. Let me type in wood. If I type in wood, I get a whole bunch. And here's an okay looking one. It's called wood 2. Now it looks really tight, I guess. So I'm going to try to increase the scale. Let's increase it to 10. Not enough. Let's try 50. Maybe we try 75. And I'll give it an angle. Doesn't really matter what you end up with. You can play with it till you get something that you're happy with. But something like this would be fine.
And then you would put on your dimensions and what's shown in the drawing, and that's it. So we basically finished the small stair section.
And I know I'm keeping you guys a long time. Are you okay to bear with me for 15 more minutes? Thank you. I'm going to show you how I would attack the bigger section. Just so you have
You get the other wood options.
for hatching. I typed in hatch, and then I clicked on this. There's like an arrow where you go up and down, and then there's a double arrow at the bottom. It gives you a bigger thing, and then in there I just started typing WOOD, and it took me to all the ones that start with wood. Do you have something? Sorry?
I only see one option.
Okay, maybe different computer more different stuff. If you don't have wood, pick anything, or don't hatch it. Feel free not to hatch it, that's okay, you don't have to. It's not necessary.
Okay, so last thing we need to tackle is the main stair section. So the way I would go after this, we kind of have all the information we need. We've drawn the stairs in detail. Okay, we've got a couple of stairs. Theoretically, we can just take those and start copying them, kind of leapfrogging like we did before. We should end up exactly correct floor to floor height. In theory, that should work. But don't even around with that. There's always a chance you're going to be a millimeter off, and when you copy that 15, 20 times, now your stair doesn't line up with your floor, and it'll just kind of fall apart. So what I would do first is to, I guess we can copy our floor sections from above. I just want to redraw all of this. No, we'll copy that later. So we will do our stair, our floor to floor heights first. So we'll draw a line for our concrete floor. We'll draw a line for our second floor, make sure it's exactly spaced correctly, and we'll draw a line for the second floor. So then we have our floor to floor heights. We can always copy these details in after. These are an afterthought. The floor assemblies and stuff. We've already drawn those before. So we need our floor to floor heights, and then we need to make sure that our stair lines up exactly the size we drew it compared to the floor to floor heights. So what it's saying here is the basement to ground floor is 2638. I'd like to check that. $2,582 is what we have. And they have some kind of a different concrete floor on top of that, which they also show in here. Okay, great. So what they're showing in the section, sorry to take you back to the main section, they've drawn a strange kind of a detail here. You can put it in if you want. Actually, I would put it in because it's in the sample. It's you a 50 millimeter, so 50 millimeter, 5 centimeter concrete topping across the whole floor, which is unusual that you would do it that thin. And they put water pipes running through it, and that creates, it's called the radiant floor. We pump hot water through those pipes, and it heats up the entire concrete floor, and so you get a nice kind of even heat throughout the space. It's unusual that you would do it that thin, and it's unusual that you pair it with wood frame construction. Usually you just build a concrete floor and no wood frame construction, or you don't do this type of heating. So it's an unusual system they're using. If you don't do it, I'm not going to take off any marks. If you do decide to do it, just note that it's 50 millimeters and it has some pipes inside of it, so space out these pipes. I'm assuming because they put that in after the fact, that's why their floor to floor heights are different. So I think we have to go with their floor to floor heights because it's their stair section. So we're gonna do 2638 as the offset from the basement to the ground floor. So I'm gonna draw a line here for the basement, offset to 2638. Okay, then I'm going to offset the next one, 2708. Sorry, having trouble here. There we go. Okay, I'm going to extend these just a little bit. I feel like it'll make give us an easier time. Okay, so we have our floor to floors, and now I need to pick a point where we're going to start our stair. I'm going to assume that the stair starts the same place on both floors. Let's see the assumption, let's see. Uh, 14 risers, 14 risers. Okay, yes, so they do start in the same place in both cases. So let's start at the bottom. That might make it easier. So I'm going to strike a line, and we'll say that's where our stairs start at the bottom. Now I'll go to here, and I can grab our stair. I'm only going to grab whole pieces. I'm not going to grab the ones that are kind of cut in half. And now this is important. The first riser, so this point right here is going to be the point that lines up with our floor, because that's the actual height of the stair that we want. So don't line up anything below this with the point. That point right there has to be where we start. So I'm going to go right there, enter. I'm going to delete this hatch. I don't need that bothering us while we're dealing with intricate things. In fact, I don't like the wedges there either, but they do show the wedges. Okay, fine. We'll stick with the wedges. This can get shortened and trimmed. Okay, so we have 1, 2, and almost a third riser. In fact, I'm going to make our job easier and kill that. And we're going to go one riser at a time. So 2 risers. Nope, I screwed up. Okay, copy. I'm going to go to that point. 3, 4, 5, 8, 13, 14. Okay, and we ended up exactly at the finished floor level of that next point. So this went really well. Now all I have to do is copy. That's my stair. Now all I'm going to do is I'm going to copy the stringer and extend it across. Okay.
So from this example, we now have this entire thing drawn. Underneath this first stair, I can shorten it a little bit if I have to. Just trying to see what we do here. We have 3 2x10s right under it, and 1 2x10 below it. So we should be able to draw that.
So 2x10, I don't know if it's a 2x12 or 2x10, but we're going to do the 38 by 240 member. So at 240 by 38. So I'm going to move it below the stair, like they appear to have drawn it. I'm going to remove these wedges for this. Okay. It looks like they have 3 of these guys. And that the stringer starts after that blocking. Somewhere in there. Okay, to get this little top detail here, it looks like what they do is they continue, I'm guessing here, because it doesn't give us a dimension, but just to give you an idea of how they did this, I think they basically extend this line to here, maybe a little further. And then they just draw it straight. Like this and like that. So that's how the stringer ends. So we have the end of the stair drawn, the beginning of the stair, they just extend the stringer, looks like about 100 millimeters beyond. I'm going to offset 100. Fillet this with this.
So we now have basically the first entire stringer drawn.
And since they're both 14 risers, my guess is that once we've drawn one, we can maybe just copy it right to the other floor, but the floor heights were a little bit different. Let me just see how much different. 2683, 2708. How does that work out in their drawing? That doesn't make sense. Oh, so these risers 14 at 193.4 and these are 14 at 188.4. Okay, so we have to draw a slightly different riser for this. Okay, so what we would have to do to draw the second stair, I don't want to, if you guys want, we can do that together now. But we are going further than we usually do. So what I would do, the way I would do this is I would redraw what we did before, but here we did it with a 188.4 riser. And these guys want, for the second stair, they want a 193.4 riser. So we would have to modify this stair slightly to get it to work for the second floor. Do you guys want to, should we take another 15 minutes and do that together? Is that okay? Okay. Just yell at me if I'm boring you guys to death. So, we have this one done. I'm going to move this guy down a bit just so we know it pertains to this floor. I'll copy it now and move it up here. It's not a big modification. I keep hitting escape. Okay. It's not a big modification that we need to do. First I'm going to get this out of here. Oops, wrong one. This hatch out of here. But I do think I need to reduce it down to one stair. Just so I don't, like if I modify one, I want to be able to copy it afterwards. I don't want to have to modify all of them because odds are I'll mess up if I try to do the same change across multiple stairs. So I'm going to say offset, and I think they want 193.4. I'll double check that. $193.4, yes. So all that means is that this has to move up to here, I think. Is that a cat? Okay, and now I'm going to check to see if I'm correct by copying this tread on top of it, and then I'll check the dimensions. I'll just arbitrarily stretch this wedge to there, sure. Okay, so distance from top, no, something messed up. That's right, I did 193.4, it should have been 30 lower, because this is 30 thick. So I messed up a little bit. So I think I'm just going to cut something out of this. I'm going to offset this 30, and I'm just going to try to trim this and move it down. Okay, let's try it again. Distance 193.4. Okay, so now we're good. So now to start the stair, I should be able to copy this guy to here. Offset is 22 wide. Oops, that didn't copy properly. to there. Okay, and this should still be 193.4 to the top. No, it isn't. What's going on here? That's 193.4. Oh, I have it as 2 lines. Okay. I'm going to trim that a bit just so they're the same height. Okay. I think we're in good shape. So I think we can try to build this second stair. So I'm going to copy what I have here. And start it here. And now I need to set myself up so I can copy this and this the same every time. So I'm going to delete this wedge. In fact, I'm going to delete this too, I think. And I'm going to copy all of this and this. And I'll make this top corner my base point. So we have 1 riser, 2 riser, 3, 4, 6, 7, we need 14. I believe that's 14. So I'm going to put 1 more there to get, I hit escape. Okay, cancel, yeah, and it worked out really well. We can delete that, and we can probably copy, I'm guessing they have a similar detail at the top of this there, exact same detail as they did below. So I can simply go down here and copy all of this and stick it on the bottom of my stair. I'll delete the stuff I don't need. Okay. Actually, no, I can't copy this diagonal line because the slope of this stair is different than the slope of the previous stair. So I need to draw the stringers again for this top one. And the way I do that is I just simply connect the corners together like so, offset by 90 on the bottom. And then I think we offset by 13 more for the drywall. And then extend. There and to there. And the bottom one becomes dashed. Okay, now unfortunately I have to refill it to the top of my stairs because I need that sharp point, just like we did previously. Once I connect those, I have the line I need and I can trim those sharp points back down. And I can offset this line 25 like we did before. Oops. Extend it here and to here. And I can finish it the same way we did before, where I extended it to an arbitrary line up here and then just gave it a square edge, kind of following the stair right up to the edge of the stair, like so. And with this one we offset it out 100 and filleted. Okay, so we have our stairs. Do we have our drawing? Okay, so we do have both stairs. Now, we still have to draw, I'm assuming you guys are okay drawing this stuff, the bridging and stuff like that. You've done it before. So to fill in these type of details, I think you're okay to do. Now, we have the stair in. The last thing we need is the railing, and it's actually quite an easy thing to do. Really, all we're going to do to get the railing, we offset this line up 1,000. Offset it down 70, that's the width we chose for our railing, and we simply connect it with pickets. The pickets, the best way to do it would be to set it up so that we land 2 on every stair, and you just copy it all the way through. I can show you how to do that really quickly as the last step, and I think that lets you finish the drawing. So, this is how I would do it. Let's do this, the top stair. Offset, no, not offset, I would copy it. We have to copy it 1,000 up, because the height has to be 1,000. I hope that makes sense. If it doesn't, let me know, and we can talk about it. Then I can offset it 70 down for the thickness of the railing. And now what I meant with those pickets, I would line up, well, let's just see where the pickets are. They're right at the inside of, so the first one seems to start, I would say here. Okay, I'm going to shorten it so it doesn't intersect the stair. I would offset that by 25. Sorry, my mouse is freaking out here. Offset 25. Okay, and then I would simply copy this to the center of the stair. Like that. No, it has to be spaced evenly. No good. Sorry, let's delete that. Let's copy it. Okay, this is, I guess this would be the best way to do it. Let's copy this to the next stair and measure the distance between them. .238.4. Okay, might be easier just to draw a line and snap to the middle. Copy. There. So now we have the middle. I can extend. I'm just going to worry about the 2 pickets, these 2 guys. I'm going to extend it up to my railing, delete this one so I don't get confused, and I'm going to copy them just like I copied my stairs. Make sure you pick a good base point so you don't get lost. Okay. Now you can see what I'm doing here. You can simply do more of this yourself. And at the end all you need to do is just, it's going to take a second, but just go to each picket and trim out the line of that stringer. so it looks like the pickets are in front of the stringer. Okay? Clean it up nicely like that. Same with any floor lines behind it. The pickets are in front of it. And that's it. That's how you do the stair. So we can do more railing, basically it's the same thing. You would simply keep copying these below, just like you did. To get the horizontal railing above, it's the same procedure. The same distance we copied up here 1,000, you offset up here 1,000, then you just draw more pickets in. So I think you guys got it. I can do more with you, but I'm worried at this point if I keep showing you how to do more stuff, I'm just gonna, it's not gonna stick. I'm just gonna get giving you too much info in one session. So why don't we end it there? Next session, I'll show you how to do the elevations. I can also handle any troubleshooting questions you have. And of course, I'm here till the end of class, so you can ask me questions if you have any. Okay? Thank you very much for your time.